Hello, let's talk about components of a classical ML task. Basically, there are these six components of a classical task. First of all, is training sample dataset. It's our objects and their features, our raw material for learning. Target or labels, these are answers we want our model to predict. Loss function is a measure of how wrong our model was from the right answer. And this guides our optimization process. Quality metrics, they measure of model performance. Model family describes learning methods like decision trees, neural networks, and so on. And finally, model evaluation. It's the moment when we're testing our model on unseen data to verify real world performance. First of all, let's look at uh, objects. Our basically our data set contains samples and objects. Sample is a collection of observed objects. Basically, it's a particular amount of objects that we gathered as a data set, and based on this data set and these samples, we will make all of our predictions that they will correlate correctly with other data. They will behave similarly with other data that we might use in the future. Objects, basically object is a single record described by features, and the features are measurable properties of an object. Target is the final value we want to predict, and the object is usually written in the form of xy equals to set of features. And basically, sample is a combination of our object and the target values. And let's look at the features and see their main properties, qualities. Features describe properties of object. And let's look at the continuous feature. As we already know, continuous, it means this particular feature can take any real number value, and we can visualize that on the number line. For example, the number of assets in the company account is continuous feature. Also, there is a binary. There are binary features, and they answer particular finite. They can answer particular finite amount of different values. Like in this case, yes or not. Just only two values could be used as an answer. Binary feature. Basically, it's one of the classical case when we use yes or not answers. For example, for all the companies whose stock prices were predicting, we can check whether they defaulted in the last 5 years or not. You might have a question why we convert words into numbers. From yes, we got 1, and from now we got 0. And why we do this convertation? Can't we leave textual description as it is? And machine learning is the world of mathematics plus computer code, so both of them work better with numbers. That's why we do that. Just a little sample of the code where we convert. Basically, it's a data preparation stage. If we have textual representation of data, like our targets are yes or no, first of all, we have to convert this to numerical data, and then afterwards we can work on this data set. The next important type of feature is categorical features, and they follow approximately the same logic as binary ones, but they are similar because both of them have limited set of values. But now there are more than two. Basically, for example, industry or a company whose stock price we're predicting is a categorical feature. Why? Because number of industries are limited. For example, there are a list of companies and their industry column, and we see the different categories like technology, energy, finance, or healthcare. Basically, in practice, categorical features are binary feature that has more than two values instead of just two. And yes, we also have to convert them into numbers when we work with them. So basically, again, there are real valued features. They answer how many assets in the company account. There are binary features, and they answer the question: did the company defaulted? Did the company default in the last 5 years? Yes or no? And the third one we just got is categorical feature. Okay, it might be company industry. So, key takeaway just from this knowledge we got: binary have only two exact values, like yes or no. Categorical limited set, more than two, but it's not unlimited. Industry, like tech, energy, finance, it might be categories of your favorite shop, like grocery shop. They have sweets, they have some spices, they have drinks, and so on. All of these are categorical features. um, and both of them have to be encoded into numbers if you want to make a machine learning algorithm from them. Another one, next one, is ordinal feature. Ordinal features. Besides categorical features, there are ordinal features. Essentially, they are categorical features that could be ordered from bad to good. Like in some agencies, they use a rating of corporate credit ratings from agencies like Fitch, Moody's, and S&P. There are ratings such as BB, A, or double A, which represent poor, better, or excellent quality. In our dataset and our model, we can convert these three types of rating as a number one, number two, and number three. to represent different rank, different rating that we put on particular category. So basically it's rank-aware transformations. Next one is set valued features. A feature can represent an entire set of values. For example, companies major competitors. It could be one company has two competitors, another has just one, third one has no competitors at all, and so on. Here, each feature is not a single number or a single category, but a set of categories. This is the main difference. Basically, these are 5 types of features and the question that they answer. Okay, and here we have gathered information, everything we learned so far within one data set. So let's look at it. And here we have 3 objects, 3 companies, and 5 features and 1 target. So first feature is our real number, continuous number, active accounts. Second one is binary feature. Is the company defaulted within 5 years? Yes or no? The third one is category, industry. Fourth one is ordinal. Is credit rating, and the fifth one is set valued. Here we can see that first object has only one competitor, the second one doesn't have, and the third one have 2 competitors. And what's missing from the dataset? We have obtained a sample of objects, sets of features, but for supervised learning this is not enough. And now we have to look at targets. Target types in machine learning, just like features. Targets come in different varieties. The type of target determines which kind of machine learning problem we are solving. First example of target is continuous value, the same as a feature we have. In the regression task, we want to know that we want to use target what takes values from continuous domain of our stock price. Second one, the same as the feature binary target. Will the stock price go up? Yes or no? Continuous real value target. When we solve regression problems, think of an infinite number line. We can always pick different values. Yes, like this example before. Different companies have different target, continual value target, and this the value we want to predict. And binary targets belong to a limited set of values, maybe just two values. This is kind of target that is used in classification problems. So instead of predicting exact value of the price, we will just ask, will the stock price go up or not? Will company be defaulted or not? And we will get one or zero answer. This is binary classification. The third type of target is multi-class target. So if binary is not enough and we want to have more answers than just two, this is the case. Which strategy is the best? For example, in the stock market, to hold, to buy, or to sell. This is example of multi-class target. And the fourth case, no explicit target, and basically it's unsupervised recommendation task. Or maybe in some samples, it's not complete data, a row of data that is not useful actually for us. It's also might be the case when we don't have a target. Basically, in such case, usually this row, this object might be deleted from the data set. So we won't distort our data set from not incomplete data. But mostly here we talk about classification case when we don't use a target. Sorry, clustering or recommendation system case, unsupervised learning case. So as a summary, continuously overload targets are used in regression problems. Stock price in 1 year, for example. Binary classification, use binary target, yes or not as an answer, and multi-class more than two. No explicit target, unsupervised recommendation systems. Building the target column, excellent. We explored different types of targets, and now we can add them to create our final data set. And let's use our three companies as an example. Suppose we are solving a regression task and answer the question, what will one share cost in a year? And let's look how we can fill our target column. On the slide we see table, and each row represents one company, one object, and they describe the object. The last column is the target. Here is a little mistake in this drawing. Here actually um, we have to have one more column. I'm sorry. Yes, we have to have one more column with the D1 object information, with D1 feature information. How many assets on the account is like a real value number. When we build model, we roll back into past. We collect characteristics, features from the past, and make insights. We look at the price of a company made a year ago, and we look at the price today. And for example, with $300 today, these $300 are actually target for features collected 1 year ago. So we looked at what features our object had a year ago, and we looked at the stock price today. That's the target, the answer to the question for the set of features collected a year ago. So from this moment, right now, today, can look at another company and predict the price in next year. Similarly, we fill in the target for the second company. The third company is not publicly traded. It has no stocks, not sell nothing. So here I just showed you one example. We don't have any features about this company. So basically, this company might be removed from our data set, or maybe used in the unsupervised learning algorithm. So basically, summary, we learned what ML is and what questions it can answer. We explored how the main components, objects, features, and labels. We saw some real examples, and let's practice in the next lesson.